Now we start a whole new category of naming compounds. So far we've spent all our time naming ionic compounds, things that have metals in them. Things that don't have any metals in them are molecular or covalent compounds, and they have a different set of rules. Thankfully, they are very straightforward rules. And the way we go about naming covalent compounds is that we assign a prefix to tell us how many atoms there are. Okay, for example, in our first example here, PCl3, 1 phosphorus and 3 chlorines. So we have phosphorus tri is the prefix for 3, chloride. So all of our covalent compounds will end in IDE. So our next example, PCl5, phosphorus pentachloride, and penta is the prefix for 5, and it still ends in ide. Okay, so in our little box here, we have the first 4 prefixes, but you need to know all 10. So I'm going to go ahead and write them over here on the left. So 1 is mono, 2 is di, 3 is tri, 4 is tetra, which is a weird one, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. So, heads up, you need to know these. Okay? So when we name covalent compounds, all we have to do is use a prefix to tell us how many atoms there are of that element. The other rule that we have is that elements to the left on the table get named first. Okay, and how that comes about is that we always name things that what we say have more metallic character come first in the formula. So if you're farther left on the table, you're closer to the metals. So you have more metallic character. So we always name the metals first. So if we're talking about all nonmetals, then the things that are closer to the metals get named first. Okay, or if you just remember things that are more left on the table go in the formula first. Right, so name this covalent compound. So we have nitrogen, and there are 2 of them. So 2 nitrogens, so I say dinitrogen. And then the prefix for 4 is tetra. And then I end in IDE. Okay, so I say dinitrogen, tetrafluoride, all one word. So di tells us there's 2 nitrogens, tetra tells us there's 4 fluorides. SCl2. So we have sulfur is our first element. And normally when we have 1, we would say mono. Okay, but we omit the mono when it's the first element. Okay, so I don't say monosulfur. If the first element is singular, we omit the mono. So I just say sulfur. And then I have 2 chlorines. So my prefix for 2 is di. So sulfur dichloride. So if there's nothing in front here, that means 1. And then di tells us 2. So 1 sulfur and 2 chlorines. Right, CCl4. So we have carbon. And if there's 1 here, there's only 1 carbon, I omit the mono. So normally I would say mono here, but if it's the first element, I leave that out. And then the 4, the prefix for 4 is tetra. So this is carbon tetrachloride. Right, the correct name for BCl3. So we have boron as our B, and there's 1 boron there, so we would say mono, except that it's the first element, so I don't say the mono part. The prefix for 3 is tri, so boron trichloride. N2F4. So here we have our first element is not singular, right? There's 2 nitrogens there, so I need to use my prefix. I only omit the prefix if it's mono, right? So our prefix for 2 is di, and our prefix for 4 is tetra. So I'll say di-nitrogen tetrafluoride. Remember, di meaning 2, tetra meaning 4. Dinitrogen tetrafluoride. Okay. So distinguishing between ionic and covalent compounds. So covalent compounds share electrons. This is important, and there should be a little N, H, H, H. Sometimes the images don't transfer to my device properly, but they share electrons. The other thing is that they are all nonmetals. Okay. Ionic compounds actually don't form molecules, they just form little attractions, positives to negatives. Okay, and they are all metals, or not all metals, but all have a metal. All right, so if you have a metal in your formula, it's ionic. If you have all nonmetals, it's covalent. So let's identify the compound as ionic, covalent, and then name the compound. All right, so taking a look, that's cobalt. That's a metal. That tells us it's ionic. Okay, so your first step to supplying a name is to determine, is it ionic or covalent? Because we have 2 completely different naming sets depending on whether it's ionic or covalent. So that's the first thing we need to determine. So now that we know that it's ionic, we know that there are only 2 things here. So this is a binary ionic. Cobalt could be a +2 or a +3. So we need to look at the fluorine to tell us. So if my formula is COF3, that means that I've got 3 minuses from my fluorine, because each fluorine is a 1 minus. So that means that I need 3 pluses from my cobalt. So that means that it's cobalt 3 plus. All right, so with our binary ionic naming, I say the name of the metal. In this case, I need to put a Roman numeral with it, and then I say the anion with IDE. So we'll have cobalt 3 fluoride. Let's identify as ionic or covalent and then name the compound. So my elements here are iodine and fluorine, all nonmetals. That tells us it's covalent. Right? If it's covalent, then I use prefixes. Right? So there's one iodine, and it's the first element, so I omit the mono. So I just say iodine. And then my prefix for 5 is penta. Right, so iodine penta fluoride, all one word. Let's identify as ionic or covalent and then name the compound. So I have sulfur and oxygen, both nonmetals, covalent. So sulfur, so if it's covalent, I want to use prefixes. All right, so sulfur is singular, and it's the first element, so I omit the mono. So I just say sulfur. And my prefix for 3 is tri. So sulfur trioxide. Is it ionic or covalent? Sodium is a metal. So we have an ionic compound. And then we recognize that SO4 is a polyatomic. So when we have polyatomics, we just name the parts. Sodium sulfate. All right, I'm going to go ahead and stop this video right here, and we'll pick it up with the next question on the next video.